You should have seen the TED video. I should have put it up. If not, talk to me, and I'll make sure I either get it up or we'll show it in class. So earlier this year, we talked about water vapor and how there's like this constant pressure depending on the temperature of the water above it, and so that's an equilibrium. It's not that the water gas up here, like those things, stay there forever. It's that hey, some of them are going to come back and they're going to hit the water surface and they're going to slow down and then some other water is going to gain some energy, and so there's this equilibrium. It's not that this water molecule up here is going to be up here forever. It's going to go back into being water, and some other water molecule is going to come up and be a gas for a little bit. So that's equilibrium without any chemical reaction going on, but equilibrium happens in a lot of chemical reactions, and not a lot more than you think. And I always think of equilibrium as a balance. I think of it as like this fulcrum, and I got my reactants on one side, I got my products on the other side, and then I have the equilibrium constant that's the focal point. And that's what my K is. And my K could be way over here if I can draw, or my K could get shift way over here. And that K can shift depending on the temperature. And so sometimes I think of K as actually the fulcrum moving, or sometimes I'll even think about energy being like, if it's exothermic, then the energy should be on this side. Because it's exothermic, it's given off. And so if I increase the temperature, it's like I added temperature here, and so I have to shift things over here. And it's important to notice if I move this thing, it's no longer in equilibrium. So to get back into equilibrium, I might have to move some things. So if it's going to be like this, hey, that rock's going to pull it down. So I got to move part of this rock over here. And you have to think of that as like in particles and stuff. And equilibrium, once again, is just a state of balance. It's a dynamic equilibrium when we talk about chemistry. And what does that mean? That means that things are moving from one side to the other always, but hey, if you're at equilibrium, the rate at which things go to the left are equal to the things going to the right, and so that it doesn't fall out of balance.